Hi everyone. Today we're going to study linear equations in one variable. Let us define linear equation. A linear equation in one variable can be written as ax plus b equals 0, where a and b are real numbers and a is not equal to 0. Example is 2x plus 4 equals 0. The coefficient of x2 is the a and the 4 here is the b. Also, let us define solution of an equation. A solution of an equation is a value of a variable that makes a true statement when substituted into the equation. Example is x equals -2 is a solution to the equation 2x plus 4 equals 0. So this value -2, when we substitute in here, it becomes 2 times -2 and then plus 4. 2 times -2 will be -4 plus 4, and this is equal to 0. And this is now a true statement. It means this -2 is a solution to the equation. Today we're going to study solving equations which have linear expressions on one side and numbers on the other side. This is the general rule. To find the solution of the equation, isolate the variable in one side of the equation. Example 1. Find the solution of 2x minus 3 equals 7. Let us isolate the variable 2x. First, this -3 must be deleted. What we will do is, since this is -3, we will add +3 to both sides of the equation. So, it becomes like this. +3 comes here on the left and +3 comes to the right. On the left side, the -3 plus 3 becomes 0. So the left side is 2x equals, the right side is 7 plus 3, that is 10. And from here, we're going to divide by the coefficient of x, which is 2. So we have 2x over 2 equals 10 over 2. We can cancel the coefficient 2 with the denominator 2. So on the left, only x remains equals 10 divided by 2 is 5. This is our solution. To check the answer, we substitute the solution, which is 5, to the given equation and check out that left-hand side, or simply LHS, is equal to right-hand side. To simplify, that is RHS. So the 2x minus 3 equals 7 becomes 2 times 5 minus 3 equals 7. Let us simplify the left-hand side. 2 times 5 is 10, then minus 3. The difference is 7, which is equal to the right-hand side. Since the left-hand side equals the right-hand side, we conclude that 5 is the solution of the given equation. Example 2. Solve 2y plus 9 equals 4. Let us isolate 2y. Let's move this 9 to the right side. Or we say that we transpose this number 9 to the right side. Since this is positive 9, when it transposes to the right, it becomes negative. Or we say that the sign changes. So we have the left side now is 2y equals 4 minus 9. 4 minus 9 is simply negative 5. Now we divide this equation by the coefficient of y, which is 2. So we have 2y over 2 equals negative 5 over 2. Then we cancel these 2 as coefficient and the denominator 2. The left side is now y equals, the value is negative 5 over 2, and this is the solution. To check the answer, we substitute the solution, this negative 5 over 2, for the y, to the given equation, and check out that left-hand side is equal to right-hand side. So this 2y plus 9 equals 4 now becomes 2 times the value of y, negative 5 over 2, then plus 9 equals 4. Let us simplify the left-hand side. In this fraction multiplied by 2, we can cancel this 2 and the denominator 2, and negative 5 comes out to be added to 9. So the answer of the left is 4, which is equal to the right side, which is also 4. Since the left-hand side equals the right-hand side, we now conclude negative 5 over 2 is the solution of the given equation. Example 3. Solve x over 3 plus 5 over 2 equals negative 3 over 2. Let us isolate this x over 3. Let us transpose this 5 over 2 to the right. So this positive 5 over 2, when transposed, it becomes negative. So the left side now is x over 3 equals this negative 3 over 2, then minus 5 over 2. Let us simplify the right side. We can see that we have here like fractions. That means we can operate on the numerators immediately. So negative 3 minus 5, we have negative 8 over 2. Then we simplify the quotient of the right side as negative 4. From here, we multiply this equation by the denominator, which is 3. So that means x times x over 3 equals the right side, negative 4 times 3. On the left side, we can cancel this 3 and the denominator 3. That means only x comes down on the left side equals the product negative 4 times 3 is negative 12. This is the solution. Now let us check. We substitute negative 12 to the x value here to the given equation. So it becomes negative 12 over 3 plus 5 over 2 equals negative 3 over 2. Let us simplify the left side. We can use the butterfly method. Negative 12 times 2, negative 24. Then plus 3 times 5 is 15 all over 3 times 2 is 6. The numerator here is simplified as negative 9 divided by 6, and this fraction is reduced to lowest term as negative 3 over 2, which is equal to the right-hand side value. Since the left-hand side is equal to the right-hand side, the negative 12 is the solution of the given equation. Example 4. Solve 15 over 4 minus 7x equals 9. Let us isolate the negative 7x. That means this 15 over 4 we will transpose to the right side. This value is positive, so when we transpose, it becomes negative. So the left side is negative 7x equals 9 minus 15 over 4. Let us simplify the right hand side. This 9 let us express as a fraction with the denominator 4. Let us multiply this 9 by 4, that is 36. We will use that as numerator, then all over 4. Note that 36 over 4 is 9. Now we see here that we have like fractions. That means we can operate on the numerators. 36 minus 15 is 21 all over the common denominator 4. And from here, we're going to divide this equation by negative 7. Since our right hand side is a fraction, we can say that let us multiply this equation by negative 1 over 7. So it becomes like this. Then we simplify the left side as the negative times negative becomes positive. Then we cancel 7 and 7. Therefore, the left hand side is simplified as x. On the right hand side, we can cancel 21 by 7. 21 becomes 3, while 7 becomes 1. Let's go now to the next line. The left side becomes x equals, we multiply 3 by negative 1, that is negative 3, and 4 times 1 is 4. So x value is the negative 3 over 4. This is the solution. Now just to check if our answer is correct, we substitute this negative 3 over 4 to the given equation as x. So we have now 15 over 4 minus 7. The value of x becomes negative 3 over 4 equals 9. Let us simplify the left hand side. This negative 7 multiplied to negative 3, it becomes positive 21 over 4. We copy this 15 over 4 down here equals 9. We have alike fractions on the left side, so we can add the numerators directly. 15 plus 21 is 36 all over the common denominator, which is 4. The quotient 36 over 4 is 9, which is equal to the right hand side value. So, since the left hand side equals the right hand side, the negative 3 over 4 is the solution of the given equation. Today we're going to study solving equations having the variable on both sides. This is the general rule. Keep all variables in one side of the equation and all constants on the other side, and solve. Example 1. Solve 2x minus 3 equals x plus 2. First, let us isolate 2x on the left. That means, let's transpose the negative 3 to the right side. The negative 3 becomes positive when it is transposed. So, it becomes like this. 2x equals x plus 2 plus 3. Then we simplify 2 plus 3. The right side becomes x plus 5. Now, let us transpose this x to the left. So, the left side becomes 2x minus x equals 5. The left side is simplified into x equals 5. This is now the solution of the equation. For checking, we can substitute the solution or this value 5 to every x of the given equation. So we have 2 times 5 minus 3 equals 5 plus 2. Let us simplify both sides. 2 times 5 is 10, then minus 3 equals, the right side is 7. 10 minus 3 equals 7, which is equal to the right side value. Since the left hand side is equal to the right hand side, then 5 is the solution of the given equation. Example 2. Solve 5x plus 7 over 2 equals 3 over 2 times x minus 14. Observe that we have fractions in our equation. For equation that involves fractions, let's multiply the equation by the least common denominator or LCD. Notice that the denominators here are equal and the value is 2. So that is our LCD. So we multiply this equation by 2. This 2 means we multiply each of the terms from both sides by 2. So we have 5x times 2 plus 7 halves times 2 equals 3 over 2x times 2 minus 14 times 2. Let's simplify both sides. 5x times 2 is 10x plus 7 over 2 times 2, that is 7, equals 3 over 2x times 2. We can see that we can cancel this 2 by the denominator, so 3x comes down, minus 14 times 2 is 28. Then we can do both things. We can transpose the number 7 to the right and transpose this 3x to the left. So we have 10x minus 3x equals negative 28 minus 7. 10x minus 3x is 7x equals negative 28 minus 7 is negative 35. We want the value of x. Let's divide the equation by the coefficient of x, which is 7. So we have 7x over 7 equals negative 35 over 7. Finally, x equals negative 5. This is the solution. To check if our answer is correct, we substitute the solution, which is negative 5, to every x of the given equation. So we have 5 times negative 5 plus 7 over 2 equals 3 over 2 times negative 5, then minus 14. Let's simplify both sides. 5 times negative 5 is negative 25 plus, we can show this fraction as decimal, 3.5 equals 3 halves times negative 5, that is negative 7.5 minus 14. Both sides equals negative 21.5. Since left hand side equals right hand side, then negative 5 is the solution of the given equation. Today we're going to study reducing equations to simpler form. Example 1. Solve 6x plus 1 all over 3 plus 1 equals x minus 3 all over 6. For equations that involve fractions, multiply the equation by the least common multiple, LCM, or LCD, of all the denominators. In our equation here, the denominators are 3 and 6. And the LCM of these two numbers is the number 6. So we multiply this equation by 6. This value 6 we multiply to each of the terms of the equation. So it becomes 6x plus 1 all over 3 times 6 plus 1 times 6 equals x minus 3 all over 6 times 6. Now let us simplify this equation. The 6 and the 3 cancels out. 6 becomes 2, 3 becomes 1. Plus 1 times 6, later we write the product, equals, we can cancel this 6 and this 6. Both becomes 1. In the first group, this 2 here, we multiply to 6x plus 1. So we have 12x plus 2, then 1 times 6 is plus 6 equals, we write down the x minus 3 here. Then we simplify this 2 plus 6 becomes 8. From here, let us transpose this 8 to the right side. It becomes negative later. And we transpose this x to the left. So we have now 12x minus x equals negative 3 minus 8. Simplifying both sides, the left side becomes 11x equals negative 11. To find the value of x, we divide equation by the coefficient of x, which is 11. So it becomes x equals negative 11 all over 11. Or simply, this is negative 1. This is the solution. Now, to check if negative 1 is the correct answer, we substitute the solution, or this negative 1, to every x of this equation. It becomes like this, and let us simplify. 6 times negative 1 is negative 6 plus 1 all over 3 plus 1, we copy down here, equals negative 1 minus 3 is negative 4 all over 6. This fraction, we simplify the numerator as negative 5 all over 3 plus 1 equals, this fraction is reduced to lowest term as negative 2 over 3. Let us simplify the left side. This one multiplied by 3 all over, we use the same denominator. So this is 3 over 3. Take note that this is equal to 1. Now let us simplify the like fractions in our left side. Negative 5 plus 3 is negative 2 all over the common denominator, which is 3. So the left side is equal to the value of the right. Then we conclude, since the left hand side equals the right hand side, we are now sure that negative 1 is the solution of the given equation. Example 2. Solve 5x minus 2 times the quantity 2x minus 7 equals 2 times the quantity 3x minus 1 plus 7 over 2. In this case, let us simplify both sides of the equation. We multiply this negative 2 to 2x minus 7. So it becomes negative 4x plus 14. We copy 5x down here equals 2 multiplied to 3x minus 1. So we have 6x minus 2. Then we copy plus 7 over 2. We will now transpose this 14 to the right, and we transpose the 6x to the left side. So we have 5x minus 4x minus 6x equals negative 2 plus 7 over 2 minus 14. The left side is simplified into negative 5x equals, we simplify negative 2 by negative 14, we see here negative 16, plus 7 over 2. Let us combine the right side. This is a whole number. We multiply the negative 16 by 2. We will get negative 32 all over. We use the same denominator 2. Negative 32 over 2 is equal to the negative 16. Then we simplify the like fractions on the right side. Negative 32 plus 7 is negative 25 all over 2. Let us solve for x. We divide the equation by the coefficient of x, which is negative 5. But since our right side is a fraction, we can also say, let's multiply this equation by negative 1 over 5. So, the left side becomes x equals, the right side is multiplied by this negative 1 over 5. And when we simplify, we can cancel this negative 25 and the 5. Negative 25 becomes negative 5, and this 5 becomes 1. Then let us multiply. Negative 5 times negative 1 all over 2 times 1 is 2. This is the solution. Now to check if this is the correct answer, let us substitute 5 over 2 to every x of the equation. So it becomes like this. Now let us simplify. This 5 times 5 over 2 is 25 over 2. Negative 2, we copy here. We multiply 2 by 5 over 2. That becomes whole number 5. Then the minus 7 comes down. Equals 2, we copy here. Multiply 3 by 5, 15 all over 2. Minus 1. And then we copy the plus 7 over 2. We simplify this 5 minus 7 as negative 2. Then we combine this 15 over 2 minus 1. Let us show that this one is a fraction. We multiply 2 by 1, which is 2, all over. We use the same denominator, 2. Note that this 2 over 2 is equal to 1. Let us simplify further. This negative 2 times negative 2 becomes positive 4 equals, we copy this 2, 15 over 2 minus 2 over 2 is 13 over 2, and then plus 7 over 2. On the left side, we combine this 25 over 2 plus 4. Let us show that this 4 is a fraction with the same denominator. So we multiply 2 by 4, that becomes 8 all over the same denominator 2. So we have 8 over 2 here equals, we multiply this 2 by 13, we will get 26 all over 2, and then plus the 7 over 2. When we simplify both sides, we can see that the left side is 33 over 2 equals the same value for the right side. Now we conclude that since the left hand side is equal to the right hand side, we are now sure that this 5 over 2 is the solution of the given equation. Today we're going to study equations reducible to the linear form. Example 1. Solve x plus 1 all over 2x plus 3 equals 3 over 8. Observe here that we have fractions on both sides. And this is about exactly one fraction on one side and another fraction on the other side. For problems like this, we will do cross multiplication. That means this denominator here we will multiply to the numerator of the other side, and vice versa. So 8 times x plus 1 equals 3 multiplied by 2x plus 3. Then we simplify both sides. 8 times x is 8x, 8 times 1 is plus 8, equals 3 times 2x is 6x, 3 times 3 is plus 9. And from here, we transpose this 8 to the right, and this 6x transpose to the left. We have now 8x minus 6x equals 9 minus 8. The left side is 2x equals the right side is 1. Then we divide the equation by the coefficient of x, which is 2. And the value of x equals 1/2. This is our solution. Now to check if our answer is correct, we substitute the value 1/2 for every x in our equation. So it becomes like this. Then we simplify and check if the left side is equal to the right side value. Let's simplify 1/2 plus 1. Let us show this one to be a fraction of the same denominator. We multiply these two by 1. That will be 2 all over the same denominator 2. So we have 1/2 plus 2 over 2 all over. This 2 times 1/2 is 1, and then plus 3 equals the right side value. On the left side, the numerator becomes 3 over 2 all over the denominator 4. Now let us rewrite our left hand side into 3 over 2 multiplied by 1 over 4 equals 3 over 8. And finally, the left side becomes 3 over 8, which is equal to the right hand side value. Then we conclude that since the left hand side equals the right hand side, then we are sure now that 1/2 is the real solution of the given equation. Example 2. Present ages of Anu and Raj are in the ratio 4:5. 8 years from now, the ratio of their ages will be 5:6. Find their present ages. We let x be any constant, and given the present age ratio as 4:5, we will write now the present age of Anu equals 4x years, and the present age of Raj equals 5x years. Now, after 8 years, this will be the expression of the ages. For Anu's age, so we have 4x plus 8. This is in years. While the Raj age equals 5x plus 8 years. And there is a new ratio given as 5:6. To show this as an equation, we will write now 4x plus 8 all over 5x plus 8 equals 5 over 6. And from here, let us solve for x. Let us do cross multiplication. We have now 6 times 4x plus 8 equals this 5 multiplied by 5x plus 8. Then we simplify both sides. 6 multiplied by 4x plus 8. So we have 24x plus 48 equals 5 times 5x is 25x. 5 times 8 is plus 40. Now, let us transpose this 25x to the left. This positive 48 we transpose to the right. Then we have 24x minus 25x equals 40 minus 48. The left side is simplified into negative x equals, the right side is negative 8. let us multiply this equation by -1 so that x becomes positive. Therefore, x equals 8. And now let us answer the problem. We need the ages of Anu and Raj. For Anu, our equation is 4x. The value of x is 8. We substitute it here. So we have 4 times 8, and this is 32 years old. This is the age of Anu. What about Raj? Our equation says 5x. That means 5 times 8. And the answer is 40. So Raj is 40 years old. Note that 32 over 40 is on the ratio 4:5. Now let us check if these numbers satisfy the second condition. After 8 years, Anu will be 4x plus 8. So that is 32 plus 8, and the answer is 40. So after 8 years, Anu is 40 years old. What about Raj? The value is 5x plus 8. So 40 plus 8, and this will be 48. Note that the ages of Anu and Raj after 8 years, if we check that this is on the ratio 5:6. So this is our final answer. Today we're going to study applications of linear equations in one variable. When we say application, it refers to a word problem. How to solve a word problem? We will have 5 steps. Step 1, read the problem and identify what is required. Step 2, represent the required value by a variable. Translate the condition into an equation. Step 3, solve the equation to get the value of the variable. Step 4, check the answer if it satisfies the condition of the problem. Step 5, answer the question with a complete sentence. Let's have example 1. Find 3 consecutive odd integers whose sum is 135. Step 1 says, read the problem and identify what is required. In here, the required is 3 consecutive odd integers. Step 2, represent the required value by a variable. Translate the condition into an equation. Before I proceed, let us review. There is an example here of 3 consecutive odd integers, 23, 25, and 27. Let us go now to represent the required value by a variable. Let n be the first odd integer. And for the second odd integer, we will write n plus 2. As we see here in the example, the difference between one odd integer to the next is 2. So we will put here n plus 2. For the third odd integer, we are going to write n plus 4, and this is with respect to the first odd integer. Look at our example here. The first odd integer is 23. The third is the 27. The gap between 23 and 27 is 4. So we write here n plus 4 as the third odd integer. Now we will translate the condition into an equation. The problem says the sum is 135. So we're going to put the first odd integer, that is the n, it's now here, plus the second odd integer, that is the n plus 2, and plus the third odd integer, that is the n plus 4, equals the total of 135. For step 3, solve the equation to get the value of the variable. So let us simplify by first removing the grouping symbol. So it's now like this, where we can now combine the variables and we combine the constants. This is n plus n plus n. We will have the 3n, and the constant 2 plus 4 is positive 6, equals 135. We want to remove this positive 6 on this side to keep the 3n alone in this left side. So we're going to subtract 6 to the left side. Also put a negative 6 on the right side. And the 6 minus 6 here will be equal to 0. So only 3n comes down. We simplify 135 minus 6, and that is 129. We want to get the value of n, so we will divide the equation by the coefficient of n, and that is 3. So the 3n divided by 3 equals the 129 divided by 3 also. We can now cancel the coefficient 3 and the divisor 3. So we'll have now the n equals 129 divided by 3 is 43. So n is equal to 43. Take note, this n is our first odd integer as we represent in the beginning. So I put the 43 for the first odd integer. To compute the second odd integer, we'll now have this 43 to be substituted here and then plus 2. And that's where we get this 45. Now for the third odd integer, again we will use the value of n, that is the first odd integer, and then plus 4. So 43 plus 4, we will get the 47. For step 4, we will check the answer if it satisfies the condition of the problem. So if we're going to add these 3 odd integers and they are consecutive, the sum must be equal to 135. If we compute this, so 135, and it is equal to 135 on the right side. So step 5, we will answer the question with a complete sentence. The 3 consecutive odd integers are 43, 45, and 47. This is our final answer. Let's have example 2. The measure of one angle of a right triangle is 50 degrees more than measure of the smallest angle. Find the measures of all 3 angles of the triangle. Step 1, we read the problem and identify what is required. So we need to get 3 angles of the right triangle. Step 2, represent the required value by a variable. Translate the condition into an equation. First, let us draw a right triangle here. Let us get one angle. We will name this as x. So in here it says we let x to be the smallest angle. And then the first condition says the measure of one angle of a right triangle is 50 more than measure of the smallest angle. It means the second angle is compared to the smallest angle, and the next angle is 50 more than. So you see the second angle here, it is compared to the first angle, and it is written here x plus 50 degrees. So this x plus 50 degrees, that is the second angle, or this another angle. The third angle is the right angle, and we know that this is equal to 90 degrees. So we have now the representations of the three angles. We're going to translate now the condition into an equation. Please note that the sum of all angles in a triangle equals 180 degrees. So we will put these three angles in an equation. So this is now the x, the smallest angle, plus the second angle, the x plus 50 degrees, plus the right angle, 90 degrees, equals the 180 degrees. Step 3, we will solve the equation to get the value of the variable. So let us simplify this. First, let us remove the grouping symbol. Since it is preceded by a positive sign, we can remove the grouping symbol right away. It will be like this now, where we can now combine the x and x, also the 50 degrees plus the 90 degrees. We have now 2x plus 140 degrees equals 180 degrees. So we want these 2x to be isolated. We are going to remove the 140 degrees here. So I will subtract the value 140 degrees on the left side. Also this negative 140 degrees on the right. So we can now cancel the 140 degrees minus 140 degrees. It becomes 0. The 2x comes down, then equals 180 degrees minus 140 degrees equals 40 degrees. We want to get the value of x, so we will divide the equation by the coefficient of x, which is 2. So the 2x divided by 2 equals the 40 degrees divided by 2. We can now cancel the coefficient with the 2 in the denominator. Only x comes down, and this is equal to 20 degrees. So take note, our x, in the beginning we say that this is the smallest angle. So we can put the value of the 20 degrees on the smallest angle. Since we have now the value of the smallest, we can now compute for the next angle. So we will use this x, the 20 degrees, in here. So this is 20 degrees plus 50 degrees. The other angle will be 70 degrees. And of course, the third angle is already there. It's 90 degrees. Step 4, check the answer if it satisfies the condition of the problem. Look at our first condition here, that the two angles are compared. The middle angle should be 50% more than the smallest. So look at this 20 degrees and the 70 degrees. The difference is 50 degrees. So that is satisfied. And also, if we're going to add the 20 plus 70 plus 90, it is equal to 180 degrees. So step 5, we will answer the question with a complete sentence. We will write the three angles are 20 degrees, 70 degrees, and 90 degrees. And this is our final answer. Let's have example 3. One side of a triangle is 3 feet less than the first side. The third side is 5 feet less than twice the first. The perimeter is 20 feet. Find the length of the 3 sides of the triangle. Step 1. We read the problem and identify what is required. And that is the 3 sides of the triangle. Step 2. Represent the required value by a variable, and we will translate the condition into an equation. Let us draw one triangle here, and we will assign the first side to be x, and we say x equals the first side. For the first condition here, it says one side of a triangle is 3 feet less than the first side. The first condition describes the second side. So if we have the first side as x, the second side will be x minus 3. This is the mathematical representation of the first condition. One side of a triangle is 3 feet less than the first side. Now let's go to the second condition. The third side is 5 feet less than twice the first. So the third side is also compared with the first side. So with the x, using the x variable, we will write like this: 2x minus 5. Let us read again. The third side is 5 feet less than twice the first. So we multiply the x by 2 and then we subtract by 5. And that is the third side. Another condition is the perimeter is 20 feet. Let us remember, the perimeter of a triangle is the sum of all sides. And in this problem, the perimeter is given as 20 feet. And then translate the condition into an equation. It means we're going to add the 3 sides. X is here the first side, plus the second side, which is the x minus 3, plus the third side, 2x minus 5, equals the total 20. That is the perimeter. So step 3, let us solve the equation to get the value of the variable. First, we will remove the grouping symbol. Both grouping symbols are preceded by a plus sign. We can remove it right away. So it's now like this. And then we are going to combine the variables, also combine the constants. X plus 2x equals 4x. The negative 3 and negative 5 becomes negative 8 equals 20. We want this 4x to be alone on the left side, and this is negative 8, so I'm going to put a plus 8 so that it will cancel this negative 8. So plus 8 is added on the left side, also on the right side. So the negative 8 plus 8 becomes 0. Only the 4x comes down, equals 20 plus 8 is 28. Let us divide the equation by the coefficient of x, which is 4. 4x divided by 4 equals 28 divided by 4. So we can now cancel the 4 and the 4. Only x is here, equals the quotient 7. So x equals 7. It means the 7, that is the first side of the triangle, and that is 7 feet. To compute now for the second side, we will use the 7. We substitute here, so 7 minus 3 equals 4, and the second side is 4 feet. For the third side, I'm going to use again the value 7, substitute in the x here, so 2 times 7 becomes 14, minus 5 is 9, so 9 feet for the third side. Step 4, check the answer if it satisfies the condition of the problem. Look at the first condition. The first condition is the comparison of the first side and the second side. It says one side of a triangle is 3 feet less than the first side. So our first side is 7 feet. The second side is 4 feet. So that is 3 feet less. And it is satisfied. The second condition, the third side is 5 feet less than twice the first. Again, it is a comparison of the first and the third. If I multiply by 2 the first side, 7 times 2 is 14, and minus 5, it will be 9. So the second condition is satisfied. Next, the third condition is the perimeter is 20 feet. If I add the sides, 7 feet plus 4 feet plus 9 feet, the total is 20 feet, and the third condition is satisfied. So we're going to put the answer in a complete sentence. The length of the three sides of the triangle are 7 feet, 4 feet, and 9 feet. And this is our final answer. Example 4. The sum of 7 times a number and 8 is 36. Find the number. We need a number here, so we let n be the number. And then we translate the statement into equation. Please notice that we have here 7 times a number. That means 7n. Here there is also the word 8. So we have the 8, and it says here the sum of 7 times a number and 8. So the sum here means we need to add the 7n and the 8. And then is 36. So this is equal to 36. Now we have a linear equation in one variable. Then we solve for n. The 8 we transpose to the right, so from positive, it becomes negative 8. So 36 minus 8 on the right side. When we simplify, the right side becomes 28. And then we divide this equation by the coefficient of n, which is 7. Dividing by 7, the left side becomes n, and the right side becomes 4. So n here is the number. So we said that the number is 4. If we want to check if our answer is correct, we can substitute this value in this equation. And when we simplify the left side, you will find out that this is equal to 36. Example 5. The sum of two numbers is negative 15. One number is 9 less than the other. Find the numbers. When we analyze this problem, it requires two numbers. So, we let n to be the first number. What about the second number? The second number is described in the second sentence. It says, one number is 9 less than the other. When we say that n is the bigger number, it means the second number must be n minus 9. Then, we translate the statement into equation. particularly the first sentence. It says, the sum of two numbers. So meaning, we're going to add the first number and the second number. So we write n plus n minus 9. And it says, is negative 15. So we write here equals negative 15. Then we solve for n. We can remove the grouping symbol and combine this n and this n. So we have n plus n is 2n. Then we copy the negative 9 equals negative 15. This negative 9 we transpose to the right. It becomes positive 9. We simplify negative 15 plus 9, that will be negative 6. And we divide this equation by the coefficient of n, which is 2. When we do that, the left side becomes n, and the right side is negative 6 divided by 2 is negative 3. So we have n equals negative 3. In the beginning we said that n is the first number. Now, let's solve for the second number. We say that the second number is n minus 9. So we substitute the value of n, which is negative 3, in this equation. So, second number equals negative 3 minus 9. And this will be negative 12. So we stop. We have now the two numbers. The first number, negative 3. Second number is negative 12. So we say that the two numbers are negative 3 and negative 12. If we want to check if the answer is correct, we check the conditions of the problem. It says the sum of two numbers is negative 15. When we add negative 3 and negative 12, the answer is negative 15. So first condition is satisfied. Second condition, one number is 9 less than the other. Observe that negative 3 minus negative 12, the answer is 9. So second condition is also satisfied. Example 6. Find three consecutive numbers whose sum is negative 54. By the nature of consecutive numbers, and we need three consecutive numbers, so we assign n to be the first number, n plus 1 to be the second number, and n plus 2 equals the third number. And then we translate the statement into equation. It says here the sum, which means we're going to add the three numbers. So we have n, the first number, plus the second number, n plus 1, plus the third number, n plus 2. And the total is negative 54. So we have equals negative 54. Then let us solve for n. First, we can remove the grouping symbols and we combine n plus n plus n. That will be 3n. Also, we combine plus 1 and plus 2. So we have here plus 3, then equals the right side, negative 54. This positive 3, we transpose, so we have negative 3. We simplify the right side as negative 57. We solve for n further. We divide this equation by the coefficient of n, which is 3. So by doing so, the left side becomes n, and the right side, negative 57, divided by 3, is negative 19. So in the beginning, we said that n is the first number. What about the second number and the third number? Let's begin with the second number. The equation is n plus 1. We found the value of n as negative 19. So we substitute it here. So the second number now is negative 19 plus 1. And this is equal to negative 18. What about the third number? The equation is n plus 2. We get the n to be that negative 19. So the third number now is negative 19 plus 2. And the answer is negative 17. Now we have the three consecutive numbers as required by the problem. So we write the three numbers are negative 19, negative 18, and negative 17. If we want to check if these numbers are the answer for this problem, first we observe that the three numbers are consecutive to each other. Next, if we add these three numbers, the total is negative 54. Example 7. The perimeter of a rectangle is 13 centimeter and its width is 2 and 3/4 centimeters. Find its length. Remember that perimeter is the sum of all sides of a polygon. In this problem, it is a rectangle. For our formula, we can write P as perimeter equals 2 times the sum of length and width. Now, let us substitute the values. P as perimeter is 13 equals, we copy the number 2, let length be L plus the width given us 2 and 3/4. Let us solve and simplify. Let us first convert these 2 and 3/4 as improper fraction. So it becomes 11/4. Then we multiply this number 2 to the terms inside the grouping symbol. 2 times L is 2L plus 2 times the fraction. And this fraction we can simplify by cancelling this 2 by the 4. So the fraction becomes 11/2. Let us eliminate this fraction by multiplying this equation by this denominator 2. So it becomes like this. And these 2 multiplied to each of the terms of the equation. 2 times 13 is 26 equals 2 times 2L is 4L plus 2 times 11/2 becomes 11. Let us solve for L. This 11 we transpose to the left side. So we have 26 minus 11 and this becomes 15 equals 4L. We divide this equation by the coefficient of L, which is 4. So L becomes 15/4. We know that L means length equals 15/4 centimeters. This is our answer. Example 8. The present age of Sahil's mother is 3 times the present age of Sahil. After 5 years, their ages will add to 66 years. Find their present ages. In the first sentence, we let x equals Sahil's age. And the relationship of the ages of Sahil and her mother is 3 times. So we write here 3x. Now, second sentence, after 5 years, Sahil's age will be this x plus 5. On the same way, mother's age will be this 3x plus 5. And in the problem it says, when we add Sahil's age and mother's age, after 5 years, the sum will be 66. So we put this in the equation. So this x plus 5 plus the 3x plus 5, total is 66. Let us now solve for x. We remove the grouping symbols and we combine like terms. We combine x by 3x, we combine 5 by 5. So x plus 3x is 4x plus 5 becomes 10. This 10 we transpose to the right. So 4x equals 66 minus 10. And the right side becomes 56. We divide the equation now by the coefficient of x, which is 4. So x becomes 56 over 4, and the quotient is 14. This 14 is in years. In the beginning, we said that x is Sahil's age. What about mother's age? This is equal to 3x. X value is 14, so we have here 3 times 14. And the answer is 42. That means mother is 42 years old. Just to check if the answers are correct, let us check the situation after 5 years. Remember that today Sahil is 14. That means after 5 years, she will be 19. What about mother? Today, she is 42, and after 5 years, she will be 47. Now take note, when we add the two numbers here, the sum is 66. So our final answer, Sahil is 14, while mother is 42. Example 9. Bansi has 3 times as many 2 rupee coins as he has 5 rupee coins. If he has in all a sum of 77 rupees, how many coins of each denomination does he have? Look at our first sentence here. It describes the relationship of 5 rupee coins with the 2 rupee coins. So we let x equals the number of 5 rupee coins. That means the 2 rupee coins should be 3x, and this is the number of 2 rupee coins. Now it says the total amount is 77 rupees. And if we put this in an equation, this x we multiply by 5, and this 3x we multiply by 2. And we add the two values, and this would be equal to 77. Let us now simplify and solve for x. We have 5 times x, 5x, plus 2 times 3x is 6x, equals 77. 5x plus 6x is 11x, equals 77. We divide equation by the coefficient of x, which is 11. So x equals 77 over 11, or 7. In the beginning, we said that this x is the number of 5 rupee coins. That means 7 pieces of 5 rupee coins are there. What about the number of 2 rupee coin? In our formula, we have 3x. X is 7, so we substitute it here. 3 times 7 is 21. This is the number of 2 rupee coins Bansi has. Now, let us check if our answers are correct. We said that 5 multiplied by 7 pieces plus 2 rupee coins multiplied by 21 pieces must be equal to 77 rupees. 5 times 7 is 35 plus 2 times 21 is 42, equals 77. The left side is 77, equals the right side. Now we are sure that our answers are correct. Example 10. The digits of a 2-digit number differ by 3. If the digits are interchanged and the resulting number is added to the original number, we get 143. What can be the original number? In our first statement here, there is a condition 1, that a 2-digit number differ by 3. Take note that when we say 2-digit number, 1 digit is a ones digit, The other number is a tens digit. So we let b equals ones digit. So b plus 3 equals the tens digit. It shows us that the two digits differ by 3. And condition 2. It says, when digits are interchanged and added to original number, the sum is 143. First, let us show the original number. b plus 3 is the tens digit multiplied by 10 to denote tens place, plus the ones digit we write here. So when we have the new number, or when we interchange the digits, this b as ones becomes tens digit. So we have here b times 10, plus this b plus 3 as tens digit here becomes ones digit. And the condition says, when we add these two numbers, the total is 143. So we can write like this: the original number plus the interchange number equals 143. Let us simplify and solve for b. We have here two groups. Let us simplify each of them. The first group becomes 10b plus 30 plus b, plus the second group, it becomes 10b plus b plus 3 equals total 143. Let us simplify each of the groups. In the first group, we combine 10b plus b. It becomes 11b, and then plus 30 comes down. Plus the second group, 10b plus b, 11b. Then we copy plus 3. And from here, we remove the grouping symbols and we combine like terms. That means 11b plus 11b, that is 22b, plus 30 plus 3. So we see here 33. Let us solve now for b. This 33 we transpose to the right. So 22b equals 143 minus 33. And the difference is 110. Solving for b, we divide this equation by 22. So b equals 110 over 22, that is 5. In the beginning, we said that this b as 5 is the ones digit. Now let us solve for the tens digit, and our formula here is b plus 3. b is 5, so we substitute it here. 5 plus 3, and this is 8. So this is tens digit, the number 8. 5 is the ones digit. If we put them together, we will get the original number 85. Now let us check if 85 is a correct answer. We put 85 plus, when we interchange, 85 becomes 58. Let us check if this is equal to 143. Adding the two numbers on the left, this is equal to 143 equals the right side value. In this case, we are now sure that 85 is the correct answer.